Hey, it's Dan Emmons, and this is Bite-Sized Blockchain.
So far, we've introduced Ethereum as a game-changing world supercomputer, and how the landscape for decentralized apps has forever changed the landscape of possibilities. We talked about use cases for AI, self-evolving autonomous organizations, and provided a special use case in the form of ICOs. But we left out just why Ethereum is so effective at this compared to other blockchains. While other blockchains focus primarily on value transfer with a transaction as the base object model, Ethereum uses the concept of an account as its base unit. This decision allowed the Ethereum blockchain to have a CryptoEconomic system built in as the base layer. The Ethereum blockchain tracks the state of every account, and all state transitions on the Ethereum blockchain are transfers of value and information between accounts. There are two types of accounts: externally owned accounts, EOAs, which are controlled by private keys, and contract accounts, which are controlled by their contract code and can only be activated by an EOA. For most users, the basic difference between these is that human users control EOAs, because they can control the private keys, which give control over an EOA. Contract accounts, on the other hand, are governed by their internal code. If they are controlled by a human user, it is because they are programmed to be controlled by an EOA with a certain address, which is in turn controlled by whoever holds the private keys that control their EOA. The popular term smart contracts refers to code in the contract account, programs that execute when a transaction is sent to that account. Users can create new transactions by deploying code to the blockchain. Contract accounts only perform an operation when instructed to do so by an externally owned account. So, it is not possible for a contract account to be performing native operations like random number generation or API calls. It can do these things only if prompted by an EOA. This is because Ethereum requires nodes to be able to agree upon the outcome of a computation, which requires a guarantee of strictly deterministic execution. Like in Bitcoin, users must pay small transaction fees to the network. This protects the Ethereum blockchain from frivolous or malicious computational tasks, like DDoS attacks or infinite loops. The sender of a transaction must pay for each step of the program they activated, including computation and memory storage. These fees are paid in amounts of Ethereum's native value token, Ether. These transaction fees are collected by the nodes that validate the network. These miners are nodes in the Ethereum network that receive, propagate, verify, and execute transactions. The miners then group the transactions, which include many updates to the state of accounts in the Ethereum blockchain, into what are called blocks. And miners then compete with one another for their block to be the next one to be added to the blockchain. Miners are rewarded with Ether for each successful block they mine. This provides the economic incentive for people to dedicate hardware and electricity to the Ethereum network. Just as in the Bitcoin network, miners are tasked with solving a complex mathematical problem in order to successfully mine a block. This is known as a proof of work. Any computational problem that requires orders of magnitude more resources to solve algorithmically than it takes to verify the solution is a good candidate for proof of work, in order to discourage centralization due to the use of specialized hardware, for example ASICs, as has occurred with the Bitcoin network. If the problem requires memory as well as CPU, the ideal hardware is in fact the general computer. This makes Ethereum's proof-of-work ASIC resistant, allowing a more decentralized distribution of security than blockchains whose mining is dominated by special hardware like Bitcoin. Now, the crypto economic revolution will not be for everyone. Next episode, we will discuss some of the practical matters for deciding whether or not your smart contract code is a good fit for use on the Ethereum blockchain. Please subscribe, like, and share.